Hello everyone, we shall start the new chapter in the discrete mathematics subject which is unit 4. It is elementary combinatorics and this is about the basics of counting, about the sum rule and the product rule. And if you like my content, please do subscribe to my channel. So the basics of counting are there are two types. So there are two basic rules of the counting. They are sum rule and the product rule. So this is one of the easiest chapter in the discrete mathematics. So you have to practice this compulsorily to score more marks in the discrete mathematics. And at any cost, you should not leave this chapter. So here in this chapter, we will just only discuss about the counting, permutations, combinations and etc. Now in this video, we shall only discuss about the sum rule and the product rule. So there are two basic rules of the counting. They are sum rule and the product rule. So first, let's discuss about the sum rule. So sum rule means suppose two tasks are there, T1 and T2 are to be performed. If the task T1 can be performed in m different ways and task T2 can be performed in n different ways, and if these two tasks cannot be performed simultaneously, then one of the two tasks T1 or T2 can be performed in m plus n ways. So we are taking the two tasks, one is T1 and the T2. So the number of ways, different ways that T1 can be performed is m. Just we are assuming that, and the number of ways in which T2 task can be performed is n. So that is like T1 is performing in m different ways and T2 is performed in n different ways. So we are, and if these two tasks cannot be performed simultaneously, so the T1 and the T2, these two tasks are not performing this simultaneously, then one of the two tasks, that is either the T1 or the T2, it can be performed in the m plus n ways. So whatever the ways are there, just you have to add it, that is m plus n. So this is a sum rule. Now again, just if there are n number of tasks you can say. So suppose T1, T2, T3 and so on up to Tk are the k tasks such that no two of these tasks can be performed at the same time. So here we have to taken only two tasks, T1 and the T2. So suppose if the k number of tasks are there, so at that time we just have to add all the different ways. So no of these two tasks can be performed at the same time, and if the task Ti can be performed in ni different ways. So this I is a variable, it can change, varies from 1 to k number of ways. So I is varying from 1 to k. So that k may be any value, either k can be 2, 3 or 10 etc. So it is starting from the n and going up to the k. This I is equals to, it is varying from 1 to k values. So this Ti can be, the task Ti can be performed in ni different ways. Then one of the k task, either T1 or the T2 or T3 or so on up to kn, whatever it is, that can be performed in n1 plus n2 plus nk ways. So this is the, just we have to add all the number of ways we have discussed here. It is in ni different ways. So here it can be performed in the all the different ways are there, those all you have to add them. So for example, if I take I is equals to 3, so when I substitute here I is equal to 3, then it can be like n1 plus n2 plus n3 different ways, and there will be 3 tasks, T1 and T2 and the T3. So we just have to add all the values of n, that is nothing but the different ways we have to add it. So that will give n1 plus n2 plus and so on up to nk different ways. So this is a sum rule, and we have also note point. A sum rule is called as the principle of disjunctive counting. So these are the two examples for the sum rule. So the first example, if there are 9 boys and 10 girls in a class, then there are 9 plus 10 is equals to 19 ways of selecting one student, either it is a boy or the girl, as a class representative. So 9 from the boys and 10 from the girls. So in a class it consists of the boys and girls, both girls and boys will be there. So in a class total number will be 19. The total number of students in a class are 19. So here we are using the sum rule. 9 plus 10 is equals to 19 ways. So there will be total 19 ways of selecting one student. We are selecting only one student from the 19 students. So it means there are 19 ways of selecting the one student from the class as a class representative. So that one student, it can be either a boy or the girl. Next, the second example is, suppose a library has 12 books on mathematics, 10 books on physics and 16 books on computer science and 11 books on electronics. So library is consisting 12 books of mathematics, 10 books of physics, 16 books of computer science, 11 books on the electronics. So suppose a student wishes to choose one of these books for study. So one student is selecting one book from all of these. So we have to add all these 12 plus 10 and then 16 then 11. So when we add all this, we get 49. So that student is wishing to select one student from all of these. So from 49 books, he is selecting one. So therefore the number of ways in which he can choose a book is 49. So from there, totally there are 49 ways that the student take or choose one book from the 49. So totally there are 49 ways. So this is about the sum rule or the principle of disjunctive counting. Now we shall talk about the product rule. Suppose that two tasks T1 and T2 are to be performed one after the other. It means the T1 and the T2, these two tasks are not performing simultaneously. So one after the other it is performing. And if T1 can be performed in N1 different ways, and for each of these ways T2 can be performed in N2 different ways. So then both of the tasks can be performed in N1 into N2 different ways. Here only the statement is there. So for each of these ways, so for each of these N1 different ways, that T2 can be performed in N2 different ways. So at that time you have to use this product rule, and that is the N1 into N2 different ways of will be there. And also we can see if there are k number of tasks are there. So at that time we shall see the formula. If T1 can be performed in N1 different ways, and T2 can be performed in N2 different ways, and T3 can be performed in N3 different ways, and so on. And so on, nothing but the Tk can be performed in Nk different ways. So that k can be any value. Then the sequence of the task. So it is gone up to k value. So at that time you can write T1 comma T2 comma T3 and so on up to Tn. So these can be performed in N1 into N2 into N3 and so on up to Nk different ways. So T1 is having the N1 different ways, T2 is having N2 different ways, T3 is having N3 different ways, and Tk is having Nk different ways. So whenever this such type of situation is there, you have to just do the product for all the different ways. And the example for the product rule, suppose a person has 3 shirts and 5 ties, then he has 3 into 5 different ways of choosing a shirt and a tie. So total number of shirts are 3 and total number of ties are 5. So he can, it is just like a combination we can say. So he can choose any of the one shirt and any of the 5 tie. So that at the time we have to do the product of these two, that is 3 into 5 is equals to 15 different ways. Let me say you one example. So 3 shirts I am taking it as A, B, C. 5 ties I am just taking it as P, Q, R, S and T. So let's name them. The first T is A, B and C, and 5 ties are naming it as P, Q, R, S, T. So he is selecting one shirt and one tie. So he can select AP or AQ, AR, AS or AT. So for this it is having the 5 ways. And similarly for B it is having 5 ways, that is BP, BQ, BR, BS, BT. So it is also having 5 chances. And C is having 5 chances. So CP, CQ, CR, C8, CT. So he can select totally 5 plus 5 plus 5, that is nothing but 5 into 3 we can say. So we are just multiplying this 5 into 3, that will give the 5 different ways, 15 different ways. So therefore the totally 15 different ways are there in which the person can choose a shirt and a tie. This is a product rule. Now we have a note point. Product rule is also called as the principle of sequencing counting. So this is about the product rule and the sum rule and the product rule, and in next session we shall discuss some important problems on this. It is very important, which can be asked for the 1 mark.